Hello, everyone. Happy Labor Day. I know we're still in class, even though it's Labor Day, but they changed the schedule. So we do have class today. So it is class number 4, and we are covering chapters 2-1 to 2-3. The videos for this week are going to be shorter. So I do have 2 videos. The first one's going to be a short video. The second one will be a little longer. But as far as that, this material is not that difficult. And I try to put it in spaces before a test. Because yes, you do have a test next week. So at the end of this lesson, or at the end of today, this video, the second video, I will go over the procedure for taking the test, how we're going to do that online, and what that's going to look like. But for now, we're going to go ahead and dive into chapters 2-1 and 2-3. So far, so good on your quizzes. You guys are all turning your quizzes in. Your work is beautiful on those quizzes. If you have any questions, you can always just email me, and I'll let you know what you missed. I've been trying to write the notes on the side so you know exactly what you missed. Those quizzes are key, so be sure you're completing them. I'd be sure to actually have them available while you're taking your test next week as well. So all of that will help. Okay, so as far as that, let's go ahead and start with chapter 2-1. Okay, so chapter 2-1, and really 2-2 for that matter, is everything on the coordinate plane. This may seem really easy, but it's going to come into play when we get into trig. Okay, so typical coordinate plane. You guys all know that this is the x-axis. Everybody knows that this is the y-axis. These are all things we already know. The center is the origin. And as far as the quadrants are concerned, hopefully you remember what quadrant's what. But if not, that is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. Now, the most important thing is within those quadrants is the negative and positive values of the points. So in the first quadrant, both of your x and y, by the way, all points are x and y, but both of your points in the first quadrant are positive. Okay, so that's going to come into play when we actually do trig, and we have to take a look at the signs of the trig answers. In the second quadrant, your x is negative, but your y is positive. In the third quadrant, both your x and your y are negative, so -3, -4. And lastly, in the fourth quadrant, your x is positive, but your y is negative. So that actually holds true when we get to trig and we start doing the unit circle with all of the angles. Where the angle ends up tells you what sign we have. Okay, so as far as that, that's a basic overview of the quadrant. I am going to require you guys to plot points. So you will have to plot points. I'm really not going to go over plotting points. But I do have one of the tests. So for example, what if I wanted you to plot -5, -1? You plot the x value first, so which is -5. So you would go left, 1, 2, 3, 4, 5. And then you would go down 1 on the y, and that point would be somewhat in that vicinity right there. Okay, so that's the idea. It's very simple, chapter 2-1, and it really ties into chapter 2-2. So, yes, we're actually already done with 2-1. Now, 2-2 does tie into that. In chapter 2-2, the big formulas that we're going to look at is the distance formula, and we are going to look at the midpoint formula. Okay, so the 2 main formulas here that are in chapter 2-2. Okay, so first off, just so we have an example on our board, I want you to plot 4, 1, and -3, -5. Okay, so we're going to go ahead and neatly plot those. I guess I could get a nice line up here so my lines are nice and straight. So 4, up 1, and I'll go ahead and label that so you can see it. And the other one is -3, -5. No, a little off. Let's go down. Oops. Okay. All right. And just for reference, I'll go ahead and call this point A, and I'll call this point B. So when I'm talking, you know what I'm talking about. Okay, so you have point A and you have point B on there. So the first thing that typically what you have to find, and you could do this formula truly with anything, is the distance between those 2 points. Now, if the distance was straight, yes, you could just count. For example, like if there was another point over here, you could just say, okay, it's 5 spaces away. If there was another point up above, yeah, you could just say, okay, it's 6 spaces away. However, this is a diagonal distance. So how far is that distance from here to there? Okay, and you can probably kind of estimate, but the distance formula will give us an exact distance to that segment. So the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so as far as the distance formula, let's go ahead and plug in our values. So as far as x's, x1 could be up there, y1 or x2, geez, not y1, x2 would be down here. Y1 would be up there for my first point, and y2 would be for my second point. So you can go ahead and label those. Filling everything into the formula here, x1 is 4 minus -3 squared plus, and keep your parentheses when you're plugging this stuff in here, 1 minus -5 squared. Okay, order of operations, go ahead and do math in parentheses first. And if I do the math in the parentheses first, both of these have double minuses, so they are going to be pluses. So plus, 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 plus. You end up with 7 squared, and you end up with 6 squared. So exponents come next. So 7 squared is 49, plus 6 squared is 36. And if I add that together, I end up with a square root of 85. Okay, now sometimes these could be simplified. So you possibly could simplify your square root, and we'll see that later. So you could break down your square root into 2 square roots and one that you could be able to do. So you could simplify that. You could also, sometimes I've seen some kids turn them into decimals as well. But you can also leave it as a square root as well. So either way, that should pop out. So square root of 85. So if I actually did that in the calculator, I'd get the decimal form of that, which should be like 9 point something. So that is actually the distance of that line segment. Now, what most people don't realize, the distance formula is actually just the Pythagorean theorem, to be completely honest with you. If you have a diagonal segment and you have to find the distance of it, you theoretically could draw a triangle here and just use the Pythagorean theorem. Okay, the diagonal part is truly just the C value in the Pythagorean theorem. So you could find this distance from here to here. So this point down here would be what, 4? This point over here then is 4, -5. So you could find out how many spaces it is over here, and then you could find out how many spaces it is here, and then you could just do a squared plus b squared equals c squared, and then you could get the value of c. So you could do it that way as well. I've actually seen students do it that way. But the distance formula does exist, and it is for a diagonal distance in the coordinate plane. Okay, the last formula in this chapter is the midpoint formula. And a lot of times in geometry, you do want to find midpoints, especially in the coordinate plane. You'll want to find the medians of triangles are usually formed from the midpoints of the triangles. So midpoint. So if I look at this red line segment here, you can kind of guesstimate like where you kind of think the middle would be. But there's actually a formula that can find the actual middle point of that segment. So the midpoint formula, remember the answer is going to be a point here. So the midpoint formula is add the two x values together and divide by 2. Add the two y values together and divide by 2. And they're dividing by 2 because it's finding an average or a middle. So the two x values are 4 and negative 3. So 4 plus negative 3, all divided by 2. And the two y values, so if I go back up, are negative 5 and 1. Divided by 2. So if I do that math, we'll have to do the top first. So 4 plus negative 3 is 1. And negative 5 plus 1 is a negative 4 over 2, which boils down to negative 2. So your midpoint for that line segment is 1/2 negative 2. And if I go back up, if I go over to 1/2 negative 2, you should kind of see that that looks like your midpoint. Okay? All right, so with that said, that is the midpoint formula, and that is the, double checking that, and that is the distance formula. So both of those formulas you will have to be able to use, okay? And that brings me to actually talk about the test a little bit. As far as formulas, you will be given a formula sheet to use on your test, okay? So I will actually show you that formula sheet here at the end when I talk about the test a little bit. Okay, so with that said, that's the first video, and that's just the short video. So the next video, we are going to go ahead and go into section 2.3, and I will see you soon.